morning, everyone. Thanks a lot for joining us today for this talk. I hope you all are doing great and you already had your coffee and charged up for the final day of ContainerDays 2024. We are going to talk about one of the important aspects of Kubernetes, and the talk title is Securing Kubernetes Edge Traffic Using TLS Encrypted Gateway. I know it's a mouthful of talk title, but I hope it will be interesting than it sounds. My name is Chirag Kyal, and I'm joined by my friend and colleague Swarup Ghosh. We both are software engineers working at Red Hat. I contribute to some of the major components and operator in OpenShift. I've also contributed to MicroShift, which is the scaled-down version of OpenShift for edge devices. Swarup, do you want to introduce yourself?
Yeah, absolutely. So we are here today talking about TLS certs. So my background includes a bit of maintenance and releasing related activities for cert-manager. We have a downstream version at Red Hat. That's something our team maintains. And day-to-day work generally includes working with different components in OpenShift. That's how it really looks like. Chirag, please.
Thank you. Okay, so let's deep dive into the topic. So first of all, we'll start with some basics of TLS certificate, which is also known as SSL certificate. So we all know that TLS certificates is very crucial in this digital landscape. It helps to protect user data. It also maintains the trust between different apps, services, and infrastructure. Let's imagine a user is trying to access the internet without a TLS certificate. So all the traffic that is flowing from the user to the internet all will be plain text. So anything, all the packets can be tampered by any unauthorized parties. But at the same time, let's assume the traffic is encrypted by TLS certificate. So all the traffic cannot be altered by any third-party unauthorized access. So we can say that the advantage of using TLS certificate is to secure the traffic that is flowing between a user and the internet. That's the main use case for TLS certificate. Now, having that HTTPS before your domain and having that sweet green lock, it's fascinating. And it portrays that you care about security. But the question arises how you are managing the TLS certificate. Maybe you are using some bot from Let's Encrypt to issue a certificate. Maybe you are using some proprietary solution to manage the certificate, to have the life cycle of the certificate. Quick show of hands if you are using some manual script to manage the certificate, like all the manual ways. Are you following anything? No, so it's good. Anything else that you are following to manage your TLS certificate in enterprise? We'd love to hear about those solutions as well. We have some interesting ways of managing TLS certificate, which we will cover down the line in our talk. Now, since we are here at ContainerDays conference, so I can assume that you are using containers to manage all the workloads. So packaging a container inside a pod, then using deployment to deploy it, sounds familiar, right? Which means you are using Kubernetes to manage all the workloads, right? So over the last decade, Kubernetes has emerged as a primary platform for container orchestration, infrastructure abstraction, CI/CD integration, resource manager, you name it. Kubernetes is the solution for you. Among all this solution, one of the important advantage of Kubernetes is declarative way of resource management. Or we can say Kubernetes follows infrastructure as a code phenomena, where you will define a desired state using set of YAML files, and Kubernetes does the best job to match the current state of the resource with the desired state. So there is a reconciliation loop which continuously checks the difference between these two states, desired state and current state. If it finds any difference, it tries to apply those changes in your cluster so that eventually your current state matches with the desired state. So this is the high-level understanding how infrastructure as code work and how the declarative approach we can follow inside Kubernetes cluster, which is pretty good and simple, right? So the question arises, cannot we follow the same declarative approach to manage our TLS certificate? Wouldn't it be great that the way we are using YAML files to create our pods, deployments, all the resources in a Kubernetes cluster, cannot we follow the same approach to create TLS certificate inside a Kubernetes cluster? The question is valid, right? And that is possible using cert-manager. So cert-manager is a very popular upstream project to manage your TLS certificate automatically inside a Kubernetes cluster. It's so popular in the enterprises that it's getting downloaded 18 billion times a year. Can you imagine? 18 billion times a year. Okay. It's the de facto solution for managing TLS certificates in a Kubernetes environment. If I go deep into how cert-manager works, so under the hood, cert-manager is a Kubernetes controller, which is very powerful and extensible for your X509 TLS certificate management. It interacts with all the different certificate issuers, maybe Let's Encrypt, your Venafi, HashiCorp Vault, and there are a bunch of other certificate providers are available. So cert-manager requests a certificate from the certificate issuers. Once it gets the certificate, it stores those certificates as a Kubernetes secret inside your cluster so that all the microservices application can use those secret and eventually those certificates. It not only requests the certificate from the issuers, but it also maintains the lifecycle of those certificates, like keeping all the certificates up to date. And you can set the expiry field and renew before field so that cert-manager can automatically renews all your certificate before it gets expired. And everything is still following the declarative approach. So there are YAML files using which you can configure your certificate, and cert-manager will take care of all those things. So we can say that cert-manager is enabling certificate as the first-class citizen in your Kubernetes cluster. Right. So once you got your certificate, now you'll have to use it somewhere, right? And we used to use certificate for our traffic management. In case of Kubernetes, there are mainly two types of traffic. One is your north-south traffic, or we call it edge traffic. This is the communication that happens from outside your cluster to inside your cluster, or vice versa. And there is another kind of a traffic that is called east-west traffic. This is the communication that happens within the cluster. Like one pod is communicating to another pod within a single namespace or maybe cross namespace. So between these two kind of traffic, we would put more focus on edge traffic today because that is the important one to secure. So when we think about securing our north-south traffic, one of the traditional way of doing that is using Ingress. So Ingress acts as a L7 load balancer, and it does the routing for your traffic using hostname and path-based matching. So this is how Ingress works. You will create an Ingress resource. You will define all the rules, and it will forward the traffic to different services and eventually to the pod and your microservices. So far, Ingress has done its job, but there are certain challenges with Ingress as well. For example, Ingress cannot handle advanced traffic. It only follows hostname and path-based traffic, but it cannot follow some advanced traffic like your header-based matching, filters, and there are quite a lot interesting stuff out there. Another challenging aspect of Ingress is that it is not vendor agnostic, right? So every vendor is having their own way of doing the configuration of Ingress, and you'll have to deal with a whole list of annotations to configure your Ingress. So it's pretty challenging. So there is a room for improvement to do the Kubernetes traffic in a more simple and intuitive manner. And that's where Gateway API comes into the picture. So we are saying the future of Ingress is Gateway API. So Gateway API is the aim of Gateway API is to standardize and generalize our Kubernetes traffic. It's been worked upon actively by the upstream Kubernetes SIG network community. So the main focus is to make Kubernetes traffic simple and have more powerful way of configuring all the Kubernetes traffic. That's the main aim of Kubernetes, your gateway API. So you can see there are a bunch of providers out there which have implemented the gateway API. Few of them, like most popular, AWS, GCP, Istio, Linkerd, there are a bunch of other. The main idea remains the same. The APIs are standardized, and these providers are implementing those APIs. So for end user, changing providers would be a one-liner change. We'll see how we can do that one. So these are a set of differences between Ingress API and Gateway API. I won't go too deep and nitty-gritties of each differences, because there was a talk yesterday discussing about how Ingress and Gateway API is different. But to summarize the thing, Ingress only support L7 routing, whereas Gateway API support all entire stack from your L4 to L7. You will have some advanced level of trafficking in case of gateway, like you can have your header-based traffic, then you have your filtering, then traffic splitting. Everything interesting stuff is out there with Gateway API, which is very tedious in case of Ingress. Then Gateway API is very friendly for plug-in, plug-out concept. You can have your extensions gets added in case of Gateway API pretty easily, which is very difficult in case of Ingress. And last but not the least, the multi-tenancy aspect. In case of multi-tenancy, Ingress follows a centralized approach, which is not very easy. But in case of Gateway API, it follows some advanced topic called reference grant. We'll see how it works in the next slide. OK, Swarup, do you want to take over?
Yeah. So we are good with Ingress versus Gateway. We already had a talk yesterday to deal with the exact differences between the two. I think at this point in time, you would agree that Gateway API is a good thing, and you would probably want to use it in your application if you aren't using it already to manage your edge traffic. And this is the diagram where basically we are trying to show you the personas, different kind of personas that are existing when we are living in a gateway world. So there's a cluster operator. It can be your cloud provider as well. It can be a cluster admin or whoever manages the cluster for you. They care about the gateway, which is the central point of traffic into your cluster. And that is where the encrypted traffic is received. And from that point to the outside world, your traffic is very encrypted and very TLS-ish. OK. Other than that, if you see, there are a few routes. You might be familiar with routes if you have used OpenShift, or even if you are using something like Istio or any other gateway providers, you might be already familiar with it. So the routes basically allow you to give you the knobs and controls to the backend service, and that actually lets you configure and filter how you want to manage your advanced traffic settings. Like you can do blue-green split, you can do maybe redirection of redirection, or name it. Like most of the gateway providers already have that things implemented for you. So in this setting, we are assuming that there are two developers, and the two developers can have their own namespaces. It can be also assumed that these are like different tenants on a cluster, and you're running one cluster with maybe multi-tenant setting and something. And you can also create like one gateway per tenant if you want. It's really like selection of labels and other things. We'll see that during the demo as well. OK, so we will try to create HTTP routes as well as TCP routes for the forthcoming demo. And there are other routes as well, like you can use a UDP route for if you want to expose something like a WireGuard or like a DNS kind of a port. You feel free to use that. And very recently, we saw that upstream in the gateway community has also released the gRPC route as generally available. So if you're using gRPC applications, it's very recommended that you use a gRPC route as well. OK, so So we are dealing with TLS certificates as the talk title says, and this is how a TLS certificate actually looks like when you are managing it with cert-manager. The certificate resource that you see that is going to be directly created by cert-manager, because we will put an annotation in the gateway that we'll come to later. And this is how it actually really works. There's a cluster issuer. We are using Let's Encrypt for this setting using Acme protocol. Feel free to use any other issuer of your choice. I would say that all the cluster issuers and other issuers that are there within the cert-manager project are quite extensive. Give it a shot. Probably whatever use case you're looking for, it already has one of the issuers, or you can otherwise write yourself. It's pretty open-ended. Cert-manager is pretty open-ended. Yeah, and once the certificate is ready and it's created, the OpenSSL private and public keys are there. You get a secret inside your namespace, and that namespace will contain the secret containing the actual OpenSSL keys which the gateway will use. Okay, so once we have an encrypted gateway, this is how it looks like. The encrypted gateway will be connected to the TLS cert, so it's the traffic is terminated at the router. Inside the router, like the TLS termination happens, and when the traffic is going from the gateway pod to the to your service or the route, it will be still plain text, and that is what you can use if you want to use HTTP route. If you're using TLS route, the entire thing can be protected as well. That's a different use case. So here in gateway, you would probably want to create that in a namespace which is managed by your cluster admin or whoever is managing the gateway entity. And the annotation is important. We would want to use a issuer or a cluster issuer annotation to specify which issuer you want to use to issue the certificate. And when you put these listeners, which are basically the ports that you want to expose on the gateway, you can get yourself this certificate automatically instantiated by cert-manager. You need not do anything, and the life cycle is totally managed. So everything, so the renewal of the certificates and the reconciliation, everything cert-manager takes care. And cert-managers, like the gateway extensions that are there, that will take care of reconciling this part. And this part is important. This is allowed route namespaces from all. You might not want to do this as well. You can use a label selector or any other kind of selection that can basically select from which namespaces and which kind of routes you are allowing on the specific gateway. That's really up to you how you want to control. Just for simplicity, we have added namespaces all for the demo, but yeah, feel free to use better level of security control over there. Okay, so this is how the complete picture looks like in terms of the demo that we have. So there's a gateway, there are multiple routes living on that particular gateway. The gateway ports are opened and they are all TLS terminated. Apart from HTTP route, I will also try to show you a TCP route, which is basically a TCP port talking over TLS. You might have some use case where you want to expose a TCP port, but you want to have it TLS protected because you don't want it to be open on the internet. This is an example of the regular HTTP route 1. So here only in the spec you just want to specify which gateway you want to configure it to, and the backend reference can be which service you are trying to redirect it to. There are other filters available in gateway as well. You might want to use them like to configure something like a HTTPS redirect or like traffic split or whatever you want. Like there's a bunch of options, and the best part is it's vendor agnostic, so you can use this. You can just quickly change the gateway class name in your provider or basis of your provider. If you're using Istio, Envoy Gateway, or GCP's AWS, whichever gateway you're using, and everything still remains the same, which is great, right? Like it helps you move between different cloud providers and different clusters, and you can still use it. Yeah, this is how the TCP route looks like. What this will do is the service, let's assume for this purpose, the service is a basic TCP port, and the TCP port is served as a service inside your cluster. That's the application that it is running, and we are terminating at the gateway. So there's the router at the gateway will have the certificate over there, and that gateway's TLS cert will basically do the encryption bit for you. So the developer need not have the pain to manage the TLS on their own. It's on the gateway, right? And same thing, you can specify a parent gateway, and the backend ref is the service which is running the TCP itself, and everything will be very encrypted. We'll show that in a bit. Okay, enough talking. I'll try to show you a demo of whatever we discussed. Let's pray to the demo gods that the demo turns out well. I'm trying to do it on a live cluster, so I just hope it works out. Yeah, so for simplicity, what I have done is I've installed Istio on my local cluster. You can use any other gateway provider you want. Any gateway, doesn't really matter because it's vendor agnostic. And I was quickly trying in the morning to see if the certificate is getting assigned. So that's also there. I'll delete that so that we can start over again. Okay, so this is how it looks like. So we have the cert-manager pods running in the cluster. The cert-manager has 3 pods, like the controller, webhook, and CA injector, bunch of responsibilities. And then once the pod once these are running, you would want to add this enable gateway API flag into cert-manager, because by default it's disabled, so it just reconciles ingress resources, so and the other certificate related stuff, but it does not enable gateway by default. So you would want to add this flag into, I believe for me I have already added it. Yeah, so we are all good. My controllers are running, all good. And I have created a cluster issuer as well. This is the Let's Encrypt cluster issuer, basic one. And this is using the Let's Encrypt's Acme server. And this has been configured to use the HTTP 01 challenge to configure itself to verify that you are the actual authoritative owner of the domain. Okay, so this is how the YAML looks like for the cluster issuer. This is important because you would want to move the knobs and dials over here to ensure how you want your certificate to be created. After that, it's really a declarative lifecycle that you want to use. Okay, I will try to create my first gateway. Second, I would say, because I deleted the one before, but yeah, there is this gateway which I will try to create. So I am opening 3 ports. One is the HTTP port, one is the HTTPS port, and the other one is the 9000 port on the same gateway. The HTTPS one and the 9000 one both will be TLS encrypted. And I'll try to quickly apply that. Yeah, so the gateway is created in the admin stuff namespace, I believe. Yeah, so the gateway is created and it's also programmed true, which means it's live. Let's quickly see what is up with the certificate. So we have a certificate, and that certificate is living as the Let's Encrypt cert secret inside the cluster in the admin stuff namespace. So you can imagine that the gateway is having the TLS cert available to it through this particular secret. This is the actual secret that contains the private key. Okay, so far so good. Now imagine that we have a developer who is having this namespace AX developer stuff, some random developer. I'll quickly try to create a HTTP dummy service, hello node kind of a service. Yeah, so yeah, so we have a very simple pod running, and we have to expose that pod deployment using a service. So the way gateway works is the service is considered backend and the route is considered front end. So it's like the front facing to the gateway is the route and the back facing is the service. So the service is where your application lives and it connects over there. And if you want to do maybe a traffic split or something, you can do like service V1, service V2, 70% traffic, 30% traffic that you can definitely do through your filters. We'll not cover that. We'll try to stick to the interesting TLS part only. So this is the HTTPS route. Really, it's the same thing which I showed you in the slide for simplicity. It's only containing the right values so that we have the stuff set up. Yeah, so this is getting created, and if you check, yeah, so this says that the route has been accepted. That means that it is functional, and I have used the hello node namespace, so hello node path. So this will, in the AX developer namespace, that will get exposed. Yeah. Yeah, just a second. Yeah, so if you see this, this is using a Let's Encrypt certificate, and that certificate is it's provided to you by Let's Encrypt through the cert-manager, and everything looks green, so you can trust this traffic. You need not worry anything about. Okay. Oh, I think this. Yeah, just. Okay. Yeah, there's this service is probably. Yeah. That's what went wrong. Just a second. Yeah, this should get you back. Yep. So. Yeah, so we have the output. Yeah, so this is encrypted, and it's verified by Let's Encrypt, so you can load balance it across your services and use it over there. Let's move to the other part, which is about the TCP route. So we have the HTTP running, and we have the HTTP S terminated at the gateway. Good. Now, if you see, if I do a curl call, it's a Let's Encrypt protected kind of a TLS cert. You might want to use something like an enterprise or whatever you feel. It's up to you. Let's create another simple deployment. It's a TCP deployment. And yeah, and this, I will try to create a TCP service and then expose it as well. Just give it a minute. Okay. Yeah, let's assume there's another developer, a hypothetical BX developer. Okay, so the TCP eco service is running. What this basically does is anything you send it, it will send it back with a hello message. That's all it does. I will create the TCP route for this. Yeah, and yeah, so once the TCP route is accepted, yeah, that means that the Istio's load balancer service will be able to contact the TCP service that is running inside. We can check this in the admin stuff namespace. Yeah, so this is the load balancer that I have, and that has the 9000 port exposed. Now let's quickly try to make an OpenSSL connection. Yeah, you see it is using TLS v1.3. It's using a Let's Encrypt cert, and yeah, I did show cert, so I can close this and I can show you the actual certificate one more time. Yeah, so this is how it looks like in OpenSSL text format. Okay, and then one more time, let's try to do a real communication over that TCP port. So anything. Yep, so it just sends back the same message and with a hello. That's the prefix that I used while setting up the service, and the entire thing is encrypted. So you can do this for any kind of TCP traffic. It may not have to be HTTP all the time, depending upon what you're willing to use. Yeah, yeah, certificates are nice. Yep, so this is how it works. Yep, so you close that connection. Yeah, so that was pretty much it for the demo. Yeah, you can also explore about UDP routes if you want. It can really work in the same manner. I believe UDP route will not have TLS encryption at this point in time because TCP and TLS are friends. UDP isn't really. So yeah, but we have gRPC routes as well, and MTLS is also slowly catching up in the gateway space. So yeah, we'll see that happening really soon. Okay, so far what we did was we used the gateway certificate in a namespace called the admin stuff, or where the administrator exists and where the gateway was being managed. Now, what if you want to keep your certs in a different namespace, like top secret or something? You can use a reference grant. In the reference grant, what you can do is you can allow the resource to be given from one particular namespace to another, and once the reference grant exists, you can simply say, like, example, NS2 has access to this secret from NS1, and the gateway can use it. So it's also really helpful. Maybe in the future this may live in a different API group because it's a broader RBAC related stuff that Kubernetes. I'll hand it over to Chirag.
Okay, thank you so much, Swarup. He has successfully secured the north-south traffic. So now we are left with the east-west traffic. That is the traffic that happens between within the cluster. Like maybe a pod is communicating to another pod within a namespace, or maybe in the cross namespace. So the question arises how we can secure the east-west traffic. So as your application grows, the managing the east-west traffic or the communication between the cluster gets pretty complex, or it's a mess, or should I say it's a service mesh. Due to the challenges of configuring the east-west traffic inside your cluster, the upstream Kubernetes community feels there is a need to simplify the way we are doing the service mesh, and they have come up with a solution called Gamma Initiative, which stands for Gateway API for Mesh Management and Administration. The focus of Gamma Initiative is to extend the Gateway API concept, and it basically simplify the way we are doing the internal east-west trafficking inside a Kubernetes cluster. So it will, as I already told you, it will standardize and unify the APIs that we already are using inside Gateway to protect the north-south traffic. We'll use the same standardized APIs to protect our east-west traffic as well. We also use the routes as a backend, and it will handle all your trafficking and load balancing related stuff. And since we need to deal with a less number of resources inside a Kubernetes cluster, we can assume that our observability and security will enhance down the line if you are using the Gamma Initiative to manage the internal trafficking inside your Kubernetes cluster. And of course, it will also follow the same phenomena of vendor agnostic. So the interoperability between different vendors will be smooth enough. So that's the Gamma Initiative. It's still in the development phase. The upstream community is working hard to make it standardized, but the core concept remains the same, that it will use the gateway APIs to standardize the way we are managing the service mesh to make the communication between your cluster. All right, I think we are good with that, and I just want to wrap up the things. And what are the key takeaways from the talk is that we can use cert-manager to automatically manage our certificates inside a Kubernetes cluster. You only need to deal with some YAMLs to get a certificate, and cert-manager will do the rest of the thing for you. And for doing the Kubernetes traffic more secure, powerful, and simplistic way as compared to Ingress, we can use Gateway API. And if you want a secure TLS encrypted traffic inside your Kubernetes cluster, we can integrate cert-manager with Gateway API, and we should be good to go. All right. I hope this talk was useful, and we thank you all for your time and patience for attending this talk. You can scan this QR code. We have uploaded all the resources related to this talk in a slide, our demo recording. Everything is available in this QR code. And yeah, you can reach out to us in this social media handle if you have any question. And yeah, we are good, and we'll look forward to your question. Thank you.
Okay, thank you very much. We have 2 questions, so let's start by the first one. So this one over there, does the Gateway API render the need for a dedicated gateway obsolete, or does it work in conjunction with these?
Okay, so the dedicated gateway is still required. I would say, like, it really is a load balancer kind of a service that most of the gateway providers implement. But the things are changing. There, you can have a gateway that does something else. Like it can be actually a WireGuard tunnel or something else. So it doesn't really have to be a dedicated gateway where all the traffic is coming and everything is centralized. You can create maybe 3 gateways, which are like 3 tunnels inside your cluster, and it's really the expressive power that is given by Kubernetes to express your gateway and traffic management. It really does not care how you want to implement it. So choice is yours. If you want a dedicated one, or you want like 5 gateways for 5 different things, it should not matter. But yeah, it does matter how you manage the resources for those 5 gateways, but that depends on the implementation of that specific gateway. But yeah, like there are pretty interesting ones where they're using quite a other kind of stuff, non-load balancer or other kind of stuff, using the existing gateway API CRDs itself. It's pretty interesting.
All right, next one. How far has the Gateway API been adopted by different gateway providers? Do you have any insight on this?
Yeah, I think like last time I checked, like 10-15 days ago, 20 or 25 plus providers were there. Major ones being, I think, Envoy and Istio, of course, and every cloud provider has their own. So I would say that the adoption is pretty good. And if you are trying to move away, it's a great time to use Ingress to Gateway tool to move away.
There is an upstream project called Ingress to Gateway. You can use that one to move your resources from Ingress to Gateway.
All right, one last question. Does cert-manager work differently in OpenShift compared to Kubernetes?
I find this question very interesting. Unfortunately, not. So everything remains the same. But yeah, we have a few additional integrations with OpenShift that comes into the picture. But the core concept still lives the same. So you are still getting the same controllers and the same kind of stuff, even when using OpenShift. It should not matter if you're using on a OpenShift cluster or on a vanilla Kubernetes cluster.
We are very proactive in doing CV fixes, as compared to the upstream cert-manager. So it's better to use OpenShift cert-manager. Yeah.
Okay, thank you so much for your session. And please, can I get a big round of applause for our speakers?
Thank you.
Thank you.